For polynomial and quadratic functions especially, we have some particular vocabulary that we need to know and recognize, and some operations that we need to go back and review from previous math classes. And we're going to use these examples to help us with those problems. So example 1 says to identify each term, coefficient, and constant of 6 times the expression x minus 1 minus x times the expression 3 minus 2x plus 12. We're going to classify the expression and then also determine whether it's quadratic. So to do that, the first thing we have to do is simplify. So I'm going to go ahead and distribute in both sets of parentheses. So I'm going to multiply the x by everything in parentheses. Then opposite of x, remember that x takes that sign when we distribute, into parentheses, plus 12. And then we look for like terms. So we have one term that has the squared. 6x, take away 3x, gives me 3x. And then negative 6 plus 12 is 6. So that is our simplified expression in standard form. So standard means that the exponent on the x is decreasing for each term. So we have 3 terms. We have 2x squared, we have a 3x, and we have a 6. The coefficients are 2 and 3 because they come off of the terms with variables. Our constant is 6 because it doesn't have a variable attached to it. And then we classify by the number of terms. So monomial means 1 term, binomial is 2 terms, trinomial is 3 terms. And because this has 3 terms, it was classified as a trinomial. And because the highest exponent in the simplified expression on the x is a 2, then yes, this is a quadratic expression. So that's our definition for quadratic. It's a polynomial with a degree of 2. Translate the verbal expression, take triple the difference of 12 and the square of x. So difference is subtraction, so we can start there. 12 minus x squared, so that's the difference of 12 and x squared. We're going to triple that. We're multiplying the entire thing by 3. And then increase the result, so increase is addition, by the sum of, again, that's another word for addition, 3 and x. So triple 3 times the difference, subtraction, 12 minus x squared, plus the sum of 3 plus x. So we're going to distribute the 3. 12 times 3 is 36, minus 3x squared. We're really just multiplying by 1 here. So this is going to be 3 plus x. Combine like terms, so we have negative 3x squared plus x plus 39, because I have those 2 constants. So this is another quadratic trinomial. Highest degree is 2, and we have 3 terms. The terms are negative 3x squared, x, and 39, and the constant is 39. For example 3, a fence surrounds a park in the shape of a pentagon. The side lengths of the park in feet are given by the expressions 2x squared, 3x plus 1, 3x plus 2, 4x, and 5x minus 3. Find an expression for the perimeter. So remember, the perimeter means that we're going to add all sides of the park. And then we're going to do the same process as before, identifying the terms coefficient and the constants. So we're adding 2x squared, 3x plus 1. We can put those in parentheses to show that they are representing different things. But because they're all positive, I don't have to worry about distributing anything. So we can go straight to combining like terms. So we have 2x squared, and again I mark through things just so I know that I've accounted for them and added them. So 3x and 3x is 6x, plus another 4x is 10, plus 5, 15x. And then 1 plus 2 is 3. 3 minus 3 is 0. So this is an example of a quadratic binomial, meaning it has two terms. But again, the highest degree is 2, so it would still be quadratic. So the terms are 2x squared and 15x. My coefficients are 2 and 15, and this has no constants.